Hey guys, Mrs. Lindsay here to give you a little demonstration about distance over time graphs and how elevation may affect the slope. Ready for a little ride? And here we go. Always wear your helmet. That's it. My course starts out on a relatively flat section. The slope is positive because I'm moving away from home, gaining distance over time. As I continue to move away from home, gain some distance, I notice that up ahead is a hill. As I climb the hill, I'm going to lose a little bit of speed. Therefore, my slope, while still positive, will be less steep. I'm gaining distance over a greater amount of time. Steep hill, less steep slope because my speed is slower. Now I come to a significantly steeper hill and I'm losing even more speed. My slope is still positive, I'm moving away from home, but my speed is very slow. So my slope is not very steep at all, although still positive. This is a hard hill to climb, and I'm going very slowly, so it's not very steep slope at all. I'm going to rest here at the top of the hill, and as I rest, I'm gaining no distance whatsoever. But time keeps moving, even though I'm not. My slope is 0. You'll notice on the graph, it's a horizontal line. 0 slope, horizontal line, no distance. But if you look ahead, there's a fun part coming up, a steep downhill. I'm going to gain a lot of speed. Even though I'm going downhill, I'm going to move away from home at a high rate of speed. That's going to give me a very steep, positive slope, distance over time. Ready? Let's go. Here I am at the bottom of the hill, and my course is over. I've gone a significant distance away from home, so the slope has all been positive. But now I'm going to turn around and go back towards home. My slope will now be negative because I'm losing distance. The distance to home will become less the more I ride. As I ride uphill, the negative slope will be less steep. As I ride downhill, the negative slope will become very steep as I pick up speed. Slow speed, not a very steep slope. Fast speed, much steeper slope. This is all downhill because I'm going back towards home. See you at home. Up. So my slope is negative, but not very steep. And now for the fun part. As I pick up speed, my slope becomes steeper and negative because I'm traveling towards home. Here I go. Morning.
Mary, you switched over.
Yeah. And ready to discuss a little bit more about distance over time and some elevation graphs. So I'm going to go and let's look at the first graph. This is a graph over distance, but what is this really about? In order to see what a graph is about, what we need to do is look at the y-axis. The y-axis here is about elevation. So this graph is really about hills. We start at 0, we're at ground level, and we climb to 500 meters in 25 minutes. That's quite a climb. But then we see another hill, and it looks a little bit steeper, and it is. It goes from 500 meters to 1,000, so it's 500 meters as well in vertical, in elevation. But you can see it's over 15 kilometers. So it really is a steeper hill. Then we have a flat section. We're not gaining or losing any elevation. So this is truly a zero slope, a flat section. And that goes for 10 kilometers. So this person is riding a flat section for 10 kilometers. And then there's a very steep downhill going for 10 kilometers and losing 1,000 meters. So, what is going on here? First section, we're climbing 500 meters per 25 kilometers in horizontal distance. Then, steeper slope, steeper hill, climbing another 500 meters per 15 kilometers. Then we get to a flat section, steady flat elevation, 10 kilometers, gaining or losing 0 elevation. And then a very steep descending downhill, 1,000 meters per 10 kilometers in horizontal. Very steep downhill. This rider climbs a hill, then climbs a steeper hill, then rides a steady elevation for 10 kilometers, then descends a very steep hill to ground level. Elevation graphs are really about the hills. The next graph is about distance. You can see on the y-axis, it's labeled miles. Miles is a distance. So this is a distance over time graph. It's miles and minutes. So in the first section, the person starts from home base. We'll call that 0. So from home base, we ride for 25 minutes and we cover 5 miles. In the second section, we continue away from home. Doesn't mean we're climbing a steeper hill, but we certainly are covering the same distance from 5 to 10. So we're covering the same 5 miles, but in a shorter amount of time. It's only 15 minutes, from 25 to 40. We subtract these, we get 15 minutes. Then what happens? Well, this person's not covering any miles at all. We're covering 0 miles in 10 minutes. This is a rest period. We're not going further away from home, and we're not going towards home. And in the very last section, we're coming back towards home, taking 10 minutes to cover 10 miles. So, what's happening here? The rider rides 5 miles in 25 minutes. The second section, the rider rides 5 miles in 15 minutes. You can see the steeper slope doesn't mean a steeper hill, but it does mean a faster rate. Then there's a period of time when the rider is resting. She's covering 0 miles in 10 minutes, taking a 10-minute rest. And then this rider is riding back home very quickly, because that seems to be the steepest slope, even though it's a negative. 10 miles in 10 minutes. The negative slope indicates the rider is going back home. So, what's happening here? This rider is covering distance. We don't know anything about elevation, so there may or may not be hills. 5 miles in 25 minutes is 0.2 miles per minute if we divide 5 divided by 25. So we're covering 0.2 miles per minute. That's the speed. So the slope is the speed. The second section, we're covering 5 miles in 15 minutes. If we divide 5 by 15, we get 0.3 repeating, or 1/3 miles per minute. That's a faster rate than the first section, and it's certainly a steeper slope. The third section is 0. It's a 0 slope. We're covering 0 distance in 10 minutes. So therefore, this person is resting for 10 minutes, going neither forward nor backwards. The fourth section, this rider is covering 10 miles in 10 minutes, but going back home. It's certainly the steepest slope. It's the fastest section. So here, the slope indicates speed or velocity, where in the elevation graph, the slope really did talk about the hills. Distance, including direction, is a distance over time graph. And remember, we can find the speed by dividing distance by time. Our next graph is over time, but now what is this about? Well, now if you notice, the y-axis is speed. This y-axis is telling us how many miles per hour this rider is riding. Again, the x-axis is minutes. So over the first 5 minutes of the ride, this person is accelerating from 0 miles per hour to 10 miles per hour. So we start from a dead stop and we slowly accelerate until we're riding at 10 miles per hour. From there, the person increases another 10 miles per hour to a total of 20. So here we go, another 10 miles per hour. And again, this is speed. So this person is going faster, accelerating even faster to get to 20 miles per hour after 3 more minutes, from 5 to 8. Now, at this flat part, where the distance graph indicated a rest, the speed graph indicates that this person is riding at a steady pace or a steady rate of 20 miles per hour. So now this is not rest. You have to look at the y-axis to see what's going on here. It's not a rest, but it's a steady rate of 20 miles per hour. Not accelerating, not decelerating, but a steady pace of 20 miles per hour. Then what happens is the person decides to quickly decelerate. So from 20 miles per hour, they decelerate to a dead stop at 0 miles per hour in 2 minutes. Okay, so what is happening here? In this graph, speed over time, the person gradually accelerates from 0 to 10 miles per hour. In the second section, the person accelerates even more, accelerates another 10 miles per hour to 20 miles per hour, but over only 3 minutes, where the first section took 5 minutes. Steeper slope, more acceleration. The 0 slope doesn't indicate a rest, but now indicates a steady speed. No acceleration, just a steady speed of 20 miles per hour for 2 minutes. And then there's a deceleration, very rapid deceleration, over 2 minutes from 20 miles per hour to 0 miles per hour. So what is this graph telling us? This rider is changing speed, accelerating and slowing down. From a stop, this rider accelerates to 10 miles per hour, quite gradual. Then makes a more rapid acceleration from 10 miles per hour to 20 miles per hour in only 3 minutes. In section 3, there was a steady 20 miles per hour for 2 minutes. In section 4, there was a deceleration from 20 miles per hour to a dead stop in just 2 minutes. Could it be that this rider possibly saw a stop sign and wanted to make sure that she stopped before traffic would come and crash into her bike? Smart move. Another reason to always wear your helmet. So that's a little bit about the 3 types of graphs. Elevation is about the hills. Distance over time is about the distance. And speed over time is about the speed. Remember, distance over time, you can calculate the speed by dividing. Speed over time, you can see the speed right off the y-axis. So that's a little bit about bike riding and distance over time graphs. Hope you learned a little bit, and we'll see you on Wednesday.